You're listening to China Manufacturing Decoded from the Sofeast Group. Welcome back to the show. Today, we're talking about designing for toughness, and the proof of this toughness is the IK rating. So think about a handheld device like drill that falls from your waist to a concrete floor. Or maybe you've got an enclosure on the job site and it gets banged by a tool bag. Toughness isn't just a word in these instances. It's whether a product passes or fails, or whether something's running or not. And that's really important. Adrian's hosting. Paul is with me. Paul, it is episode 300. Quite a milestone.
You know what? It's like several episodes ago, 290, whatever it was, and I'm thinking, I really hope I hit the 300 mark, and here we are.
It's happened.
Excellent. So anyway, Adrian, it's a pleasure to be back, sir. Thank you for asking me to come again. I always enjoy the British takeover.
Indeed. Well, you were recently working with a customer. We're not going to say exactly on what, of course, right? And you came into contact with this particular topic, so the IK rating. And then you mentioned to me, you said, actually, we should probably speak about this on the podcast. And it's something that I think listeners can benefit from knowing about, because not all, but at least some of our listeners are probably developing products that need to have a specific kind of toughness.
Well, that's right. So when we're talking about ratings, so everybody talks about IP rating. In other words, like the ingress or protection of water or dust. And when we're talking about IK rating, that's a different ballgame. And it's like, IK rating, what is that all about, really? And it's all about, as you said earlier, the toughness of a product or a system, let's say. And it's all about making sure the system itself is robust enough in order to carry out the job it's been designed to do. Now, you mentioned earlier on the job site, if you've got a drill, so the scenario would be that the roofing guy, okay, he's got an impact drill or sort of one of these pneumatic sort of nail guns. Okay, and it slips out of his hand, it drops down. You're doing some roofing. And this could be a single story or a 2-story. I wouldn't go any further than that, personally. The product needs to withstand that height drop. Okay, now if that was made out of glass, clearly, it's not going to be fit for purpose. If it's made out of concrete, it's a different ballgame. So the material itself is very, very important from a choice point of view in order to protect the system or the product that is being designed. Okay, in this case, it's an industrial product, or an industrial drill, or a ruggedized drill, or a product that's being used on a website, on a work site, building site, and that clearly needs a higher rate of protection or a higher IK rating than a product that you or I that's going to be used in home. For example, we're going to use like 3 or 4 times a year, so I'm going to put a shelf up on the wall. And that's basically as much as my skill set comes when it comes to building a house.
Sure.
So, you got the same products, but different requirements. One has to be very ruggedized. The other one needs to be less ruggedized because it's going to be used less in a totally different environment. And it's all about protecting the system. And this is where the IK rating comes from.
So we're gonna look into kind of how to measure that and the sort of tests that might be run, right? And then I think that you will go on to talk a little bit about some of the materials, such as some polymers that might be relevant. But that comes afterwards, because before you get to selecting materials, you need to know what level of toughness and what sort of IK rating you're after, right?
Yeah, correct. So let's put this together as more like a puzzle. Okay, so there's a number of pieces of the puzzle in order to get to the ultimate IK rating of what the product is. So let's walk through this podcast pieces of the puzzle as we're moving forward, and towards the end, hopefully we'll get a complete picture of exactly where we are. So,
Cool. Absolutely. Okay. Well, the sensible starting point then is to kind of just explain what an IK rating actually is.
yeah, let's start at the beginning. It's always a good place. So the quick definition of the IK rating is the impact strength or the toughness, and which is the IK rating is measured in joules. In other words, it's the impact energy. Okay, so if you can think of, okay, let's go back to basics. Let's look at the Izod or the Charpy test. Okay, and this is basically where the material is tested for impact strength. Generally,
Mm,
this is where you can actually look at your polymers or different materials that are being used in order to soak up the energy, if that's required. And surely, when we're talking about toughness, that's exactly what we're talking about. So it is the ability to absorb energy and resist fracture from a subjected or a sudden blow or drop or some sort of abuse. Okay, so that's basically what we're looking at. So if we sort of cast our minds back to when we we're doing all of our engineering training, boys and girls, we were looking at the
mm,
ISO or the Charpy test machine. Now, this machine is basically it's a large pendulum with a fixed weight that is raised, where you got the sample at the to the bottom of the swing angle. Okay, and that is held in a fixed vise, let's say, and then the pendulum is dropped, and it's the swing then strikes, or the hammer strikes the sample piece, and it's observed what energy is impacted. Okay. Now,
mm,
strain gauges and various different other gauges attached to the actual sample piece itself. So if you've got a brittle piece of material that you're testing, this is going to shatter and it's going to give you some information. If you've got a piece of rubber in there, for example, that's going to take up all of the sort of the energy, and the bullshit or the hammer is just going to like bang and just sort of fall against the sample piece and not move. Okay.
mm,
Sometimes if you got a piece of sample in the middle, the hammer could actually bounce back a few times. So this is what the Izod and Charpy sort of test is all about. It actually measures the impact energy that a piece of material can sustain. Okay. Now the difference between the Charpy and the Izod, one has sort of notch in it and the other one doesn't, or one's facing away and the other one's facing. Very, very similar sort of tests, which I'm not going to go into details. But ultimately,
mm,
we are testing for the amount of energy a material can withstand. Okay, and this is what the IK rating is all about. Okay, so that's basically setting the scene from going back to basics sort of point of view. So, and we are actually from there, we can start to understand what materials actually fit into the IK rating. Now, let's talk about the IK rating a little bit more, Adrian, if we can. So, the
yep.
guide to this is the IK rating goes from IK00, which is the virtually a piece of glass, let's say, to IK10. Okay, and we've got sort of various different numbers in between. It goes from the sections go IP00 to IP03, then you've got 4, 5, 6, 7, 8, and 9, 10. Okay, so they're the numbers that would be specified on a requirement, a sort of product specification document, and really
Mm,
to understand where you are looking. Now, once you understand what the IK rating is, now that's the first part of the puzzle. Okay, the second part of the puzzle is to understand what your product is going to be used in from an environmental point of view. Okay, so in other words, what's the real world going to throw at your products that you are
yep.
looking at designing? Now, I'm going to go at 3 levels here. Let's go at sort of the bottom level, and then we go a mid level, and then we'll go to the top level. Just an example before we move on to the next piece of the puzzle. Let's say,
Hmm.
so real world scenario is really where you've got to understand what your product is doing. and what you need to protect it against from an impact point of view. In other words, your IK rating. Because at the moment, you don't know what IK rating you want. You understand the scale, okay, but you need to work out where you are. So at the bottom of the scale, we would be looking at, for example, okay, where we've got a light incidental or accidental brush, where someone brushes up against a product. It doesn't really impact anything. It's not going to knock anything over. So it's almost like you walking past somebody else brushing shoulders. Okay. So it's this type of thing. For example, this could be a light switch which has a low profile. It's against the wall. If you brush against it, you're not going to break it. So this is where the low level IK rating real world scenario comes into play. Okay.
Yep.
What type of material? Well, we'll come on to that later. Okay. But at the moment, we're looking at what the real world scenario is with respect to what is required from the IK rating. Okay. An example in the middle, so somewhere around the 6 or the 7 mark, would be if, for example, you were to kick something, okay, or it would fall from the bench, okay, or something like a wrench or a something out of the toolbox would fall from the bench onto the product itself. Okay. It needs to withstand that type of impact or that type of abuse in order to pass the IK6 or the 7 range. Okay. So that's the thing we're looking at. And the type of product that would come into that range would be security cameras, enclosures in workshops, commercial door panels and stuff like this, where where they're actually subjected and open to a little bit more abuse from either the general public or the workplace environment. Okay. Unlike in the home, where we initially talked about the low impact requirement of the light switch, because no one's going to go up and smash the light switch with a hammer on purpose. We're talking about in general day-to-day use. Okay. You're just going to brush up against it. I've never broken a light switch in my life just by brushing up against it or leaning against it. Okay.
Yep.
So let's go to the top end where we're looking at the IK10, which is the top of the sort of the requirement range from a ruggedized or toughness point of view. And this is where we're talking about severe impact, like a sledgehammer impact. Okay. This is like some serious energy going on. And the next part of the equation, I'm going to look at the joules or the energy levels. Okay. So we're looking at high security equipment, military communications, automotive industry stuff, aerospace, all of this high impact, high risk products, let's say, that need that protection, that need that toughness. If they break, there's some serious consequences because of it. Okay. So we've got those 3 levels of examples, let's say, when we're talking about the IK rating in the real world scenario. So that's the next part of the puzzle you need to actually understand what your environment is going to be from the product that you're actually producing or designing. Okay. So that's basically where you are from there. Right.
And when you're developing a product, you are hopefully going to be answering some of these questions anyway, because it's really important to consider the use cases of the product by your potential customers when you're even looking at product features and things like that. So it's not a stretch to then look into the toughness required and the IK rating at the same time.
Well, that's right. In the product specifications that sort of come across my desk, which have been quite a few, I don't think anybody's actually stated an IK rating. But it is very, very clear that they have gone into detail with respect to what the product is going to be used or the use case, as a real world scenario. So that's they've got a very, very clear understanding of that, but they haven't actually tied that to an IK rating.
Right. So it's a way of formalizing that toughness required in a way. So instead of telling you, saying, Paul, I need my device to be rugged, right? That makes sense to me, but what does rugged mean exactly? So you're formalizing it.
Exactly. So the IK rating does actually put some boundaries around the specification, as opposed to one of the things we talk about is color a lot. Oh, I know this is a slight segment or a segue, but we're talking about making sure that the specification of your product is as clear as possible. And a lot of people come through, I would like my product white. Yeah, okay, but what type of white? Well, it's as close to apple white as possible. Right, okay. A little bit more detail, please, because white doesn't just come in white. It comes in like 500 shades of white. So having a round number or a Pantone number actually specifies the color. Okay. See, I want the product as tough as possible. And I need it ruggedized. Okay. So what does that actually mean? But if you come to me and said, I want it ruggedized, but I only need it up to IK08, now I know exactly where we're looking at.
Yep.
Okay. So that makes a big difference. And I don't think I've actually seen an IK rating on any of the product specifications that I've been working on in I'm not going to tell you how many years.
Interesting. Interesting.
So,
but it's not to say that you shouldn't. And so, this is definitely food for thought.
Yes.
Okay.
So that's that. So that's the next part of the puzzle. Moving forward, we really need to start matching up materials. Okay. Now, when you're talking about materials, we need to have a look at the specifications of the product from an impact strength point of view. Okay. And this is where I said we're going to start to look at some of the numbers. Okay. So if you look on the bottom end of the sort of the chart, as it were, IK00, we can start to understand that the joules or the energy required in order to meet the IK00 is 0. Okay. In other words, it's totally brittle. And this is where your glass would do. In fact, I'd never make a glass drill, but you know what I mean. But when we're talking about the IK03, we're talking about an impact energy or the joules of 0.35. So now we've got the 0.35 data point, we can start to have a look at through our polymers to understand which polymer can actually withstand 0.35 as a minimum. Okay, so this is where we need to start looking at the polymers itself with respect to what joules or impact energy ratings they are stated for. And this is where your technical data sheets or your material specification data sheets come from. Okay, so it's important to understand the materials in detail with respect to what their joules or impact energy ratings are. Okay, in order for you to look at where you are with respect to what IK rating. Now, don't forget, going back to the previous part of the puzzle, what environment do we need to protect it in? Okay, so I'm going to quickly rattle through these. IK04 is 0.5 joules, 0.7 joules is the 0.5, 0.6 is 1 joules, 2 joules for 7, IK08 is 5 joules, IK09 is 10 joules. These are thereabouts, and IK10 is up to 20 joules, which is quite an impact withstanding. So you've got that data point. Now, you need to start to have a look at what your materials are going to be in order for you to make the decision with respect to what is the right polymer in order to match the impact specification requirement. Now, I'm not going to go through everything, so I'll just give you again just a few examples, Adrian, if that's all right. So let's pick one out here. For example, a low to moderate sort of product requirement of something like IK06, which would require joules or impact strength of 1 joule. So I've now got my polymer data sheet spreadsheet in front of me with all of those filtered out that actually meet the 1 joule. Okay. So we're looking at products or polymers like polypropylene or high impact polystyrene or unmodified nylon from ABS is another one that meets that criteria. So we're looking at some pretty good polymers that can actually match our requirement straight out the gate. Okay. So, which is cool. Now, some of those products could involve, for example, household products like your heater or your air conditioning controller. Now, these get dropped around. Well, they certainly get dropped around my house quite a lot. With the amount of sort of air conditioning I've got, and all the 4 kids running around, and the dogs jumping up and down on them, and all the rest of it. They need to be pretty rugged. Not as my sort of ruggedized drill from the builder's site, but you know, this product is abused in my house. I'm hoping it's not as abused in your house, but it certainly is in mine. Another one would be a household printer, for example. This gets moderate use. Okay, moderate use, especially if you've got kids that have got homework and they need to print off, and they make mistakes and they need to print off again, and they're slamming the drawer shut and they're opening and filling the ink and throwing the paper in, etc. So that's basically where we are, and that's a good example of what the polymer could be with the IK rating of around 0.6 and the typical type of product in the environment that's going to be useful. Right, let's go to the other end. Let's go to 0.09, IK09. Now, this is a fairly high impact requirement of 10 joules, which is pretty high from an impact point of view. Your polypropylene is not going to stand up for it, okay? But your modified ABS, we talked about the sort of the ABS in the 0.6 earlier. This is the unmodified low ends. Now, if we're talking about high ends, we're talking about high impact engineering polymers and plastics, specialized products here. You need to have the high impact modified ABS. You're looking at the PC ABS. You're looking at modified impact fillers for the PA, for example. So you can see there's a trend here. There's blends or modifiers being added to the base polymer in order to improve the impact strength, in order to meet the IK rating for a product, something like a heavy duty tooling, battery case. We are talking about the builder's drill that could be dropped off the roof. So we're at that level now. So we're not looking at the simple ABS. We're not looking at the simple high impact polystyrenes. However, that's a very, very good polymer. We have to start looking at the modifiers and the blends when it comes to the polymers. Okay. So let's park that one there. So I think that's the next part of the puzzle. Okay. So we're looking at identifying the impact strength specification requirements for the polymers themselves. They're matching that back to the environment and then matching that back to the IK rating requirement. Okay, so you can see now we're starting to build that picture.
And this is an interesting conversation that you're going to need to have with your manufacturer. There's definitely going to be some dialogue on this as you discuss the options. You've mentioned polymers. I suppose it's fair to say it may also be materials that are not polymers as well.
Oh, it could well be. It could well be.
Right.
Yes.
So I'm thinking like carbon fiber or something,
Carbon fiber, Kevlar, all the rest of it that actually does fit into this. However, let's I'm just keeping it within the realms of the sort of the plastic injection molding, the polymers, and I guess this is the bonus part of our previous series that we've done.
Yeah, trilogy. Yes, recently.
We've already done that, so this is more of a bonus add-on, let's say.
Sure, sure.
So
okay.
So we've now chosen our polymer. Okay, but that's not the end of the story. Okay, that's not the end of the story. What we need to do now, because don't forget, we're looking at a system IK rating. not a material IK rating. So when I'm talking about a system, this is all about the finished products, because we need to look at the protection of the product itself. Okay, the drill that drops from the roof on the second story with the builder banging in or nailing in or whatever he's doing. We're not looking at the how sort of rugged the handle is. We want to make sure the product itself can work again. In other words, does the motor run? Does the switch actually move in and out? Does everything rotate as it should do? Does the speed vary as it should? So it's the overall system or the product itself that we need to look at. Now, while we've been talking about polymers or plastics, let's move on to the next piece of the puzzle, which is all about designing for IK rating. Okay, so we've now selected our polymer. We know what the product is. We know the environment that it needs to be working in and protected against. Okay, so we now need to be looking at things like wall thicknesses. Okay, we need to be looking at ribs and rib locations, part geometry. In other words, if you've got any sharp edge or a sharp corner, that's a stress concentration area where we're likely to see cracks form. Cracks forming means ultimate failure over a period of time. So we need to have nice radii in all of the corners where we've got ribs, and any sharp corners need to be eliminated in order to prevent these stress concentrated areas. Okay, so we're now looking at, and again, going back to our trilogy earlier, is the manufacturing process itself. Let's stick with injection molding. Okay, injection molding is primarily a very, very good process in order for all of the products that I talked about earlier. The light switch on the wall. We're talking about the battery case. We're talking about the builder's drill, or whatever the case may be. All of those housings are going to be injection molded. Now, if we've got something like the gate position in the wrong place, that could mean we're getting a weld line or a weld front where the two melt points of the polymer as they come into the actual tool itself, where they meet, that becomes the weld line. If that's in the wrong place, that could potentially create a stress concentration point, which will ultimately be your failure in the product if it's dropped or banged or crashed or whatever the case may be. Okay, so something as simple as the gate location on the tool is key when it comes to IK rating. So this is what I'm talking about. It's not just about choosing the right polymer or understanding what environment the product's going to be used in. It's the complete system overview, and it really has to be the complete picture in order to make your product a very reliable product that can meet the required IK rating. Does that make sense?
Yep, absolutely.
Cool. I think we're getting there. We're getting there. So we talked about the IK rating. We've talked about the impact strength, going right back to our college days with testing the Izod and the Charpy testing. We've looked at all of that. We also need to be looking at the polymers, matching the polymers against the impact strength, understanding it. So we're basically building up a picture. Okay, I think we've got sort of a few pieces of the puzzle left, Adrian, before we've actually got where we need to be in order to rubber stamp our IK rating product. Okay. So that is really looking at putting everything together. Okay, so we've looked at all of the materials. We've looked at everything like this. We've looked at the polymers. Now we need to understand the environment itself. Now, we know that we've talked about, let's stick with our builder friend who keeps on dropping his drill off the roof. Bless him.
Yep.
Now, where is he? Is he in the Philippines? Is he in Antarctica? Is he in America? In other words, it's not just the environment, but it is the environmental conditions that also need to be considered. Okay. So we've talked about different polymers are very good at being processed in different ways. We've talked about adding fillers or blending different polymers like PCABS in order to improve the impact resistance. What we haven't talked about is low temperature performance, high temperature performance, UV resistance, cost, chemical resistance, okay, and all of these other attributes that need to come into making sure that this complete system does meet the IK rating that is required. Now, if you've chosen a nice, well-branded PCABS for your product that's going to be IK08 rated, and that's going to be our guy on the roof with his drill, great. But have you actually looked at the temperature that could be used in? If that's in northern Canada, for example, where we've got one customer, he's very, very happy to tell me that temperatures get down to minus 45 degrees at some point, which I really can't imagine. You know, living in the Philippines and everything is fantastic. But if that drill is dropped, I can't imagine anybody working on the roof at that temperature. But if they were, for example, and if that drill was dropped, what's going to happen? Is it still going to withstand that drop? Or is the polymer impacted or changed enough that it will fail because of the low temperature? Now, probably minus 45 degrees is a little bit extreme, but you get the point. You know, we need to have a look at the environmental impact during our selection of polymers in order to meet the IK rating requirements. Totally. Okay. Now, there's obviously trade-offs. Yeah. The higher the impact, potentially the higher the cost of the polymer itself, because we're looking at additives. You mentioned sort of carbon fiber. Now, some of these polymers do have carbon fiber additives in order to make it really, really tough. Okay. That's quite an expensive polymer straight out the gate. Right?
Yep.
Is that acceptable? Is that acceptable for the product that you are designing? Something you need to consider. I can't answer that. You can't answer that, Adrian. Only, you know, if you're doing your product, you need to do this sort of analysis to make sure everything's okay. Chemical resistance is another big one. What is the environment that's going to be used in? The guy on the building site keeps on dropping his drill off the roof is totally different to someone that is working in the oil industry, for example, or an environment where there are harsh chemicals. Okay, both guys are using drills. Yeah, but one may have a totally different requirements than the other. Okay, IK rating. Sorry, I nearly slipped then. IK rating could be very, very similar, but the polymer or the design could be totally different. Okay. So it's the overall picture. It's the holistic design that you really need to be considering when we're looking at the IK rating of any product itself.
Okay. That gives us a really good grounding into it. Yeah, I'm thinking like when NASA design a drill for use by astronauts, you know, I don't know how much it's going to cost, maybe like $2 million for a drill. And even a very sturdy one for tradesmen, maybe what, a couple of $100 maximum. So there's a big difference. Yeah.
Yeah. And there's something that you and I would do. Well, certainly, I'll speak for myself. I won't assume anything from yourself, Adrian. You know, I'm talking about a $50 drill. Yeah, when I go this one. Yeah. Why?
Sure.
Because I don't need to use it very often.
But I think the useful takeaway here though is that this is something that you can easily slot into your initial dialogues with a manufacturer or within your team when you're actually developing your product, because you're going to be thinking about use cases anyway. You're going to be thinking about environments. You're going to be looking at what the users may be doing wrong. So at the same time, you could also consider the IK rating and the toughness that's going to be required. And as you've said, if you go to your manufacturer and you're already clued up on IK rating and you can say, I probably need something that's around a IK06, then they can immediately start researching what's going to work and give you those options. So instead of having some extra runaround and maybe, more work and more costs, that's a good thing to get right from the start.
Exactly. I think you nailed it. And it's not just all about specifying IK rating. We need to design for IK rating. Remember,
yes,
this is a system rating, not a polymer rating or a material rating. Okay, so I think that's a key takeaway. I think that basically gives us the full picture, Adrian. I think we're there.
Excellent. What a way to close out episode 300. And so thanks, Paul, for joining me today. I've enjoyed this one. And to all of the listeners, if you've been with us from episode 1, we thank you. And if you're new, we also thank you. But here's to another 300 more.
Hey, let's go. All right. Pleasure, Adrian. Thank you.
Great. Back next week.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.